Day. Welcome again to this new lesson on vector analysis. In this video, we'll be discussing the divergence of a vector and the divergence theorem. So, after defining the gradient of a scalar function, ngayon naman gusto naman nating ma-define yung spatial derivatives ng isang vector function. So, para malaman natin yon, we have the divergence of a vector, and then meron din naman tayong curl of a vector. So in this video, we'll be discussing or we'll define kung ano yung divergence, and then sa susunod na video naman yung curl. So para mas maintindihan natin yung idea behind divergence of a vector, we first look at some physical quantities with which we are familiar and which lead to the definition of divergence. So consider first the two vectors na kasi ganito yung tsura niya. No? So let's say, meron tayong vector na ganyan. And then, yan, ito yung ating velocity. Okay? In this direction. So for example, yung ating velocity dito is constant. Okay? And yung ating direction, hindi nagwa-vary. So, isang length ng natin. For example, this may represent a flow of water in a channel na o kaya current sa isang conductor. If we draw any volume in the flow, the total net flow of the volume is zero. Tama? That is, the total amount of water or yung current na nagpo-flow into a particular volume V is equal to the total flow out of that particular volume. Okay? So, meron pa tayo sa pang illustration. For example, dito meron tayong point source and meron tayo dyang object. No? And kasi meron tayong vector coming out from this point source, going out or radially going out. Yan. At all directions, sabihin natin din yan. Okay. Then meron din dito. Yan. So the radial flow or the radial from the center nitong ating point and the vector changes. So let's say as we go from the center to palayo, nagbabago yung ating flow. So yung length ng ating vector magsasabi na lumiliit yung ating magnitude. So habang lumalayo siya sa center, lumiliit yung magnitude. So a physical situation similar to let's say spherical, in which yung holes were made and assembled connected sa hose. Let's say meron tayong water hose and then binutasan natin. Pag yung tubig dumaan, palabas siya, di ba? So at all directions, doon magpo-flow yung tubig. Kung mapapansin natin, habang lumalayo siya doon sa butas, pahina ng pahina yung flow. So same din ito ng principle ng divergence. Now, if we were to draw a volume, so the total amount of yung water entering dun sa volume is larger than the amount of water leaving at the same volume. Kasi yung water velocity changes and the amount of water is directly dependent on the velocity. So, dun sa binabanggit natin dito sa dalawang example, there is a net flow of water o kaya kanina sa current into the volume through the surface kung na nakaka-enclose dun sa volume natin. So, ibig sabihin, meron tayong volume, merong flow dun ng vector, and depende dun sa surface na nakaka-enclose dun sa volume, yung total net flow dun, malalaman natin. Okay? So, di-define natin yung mamaya. Sabi, the total flux doon sa volume given by the surface or closed surface is actually given by a particular formula. Kung maaalala natin, ang formula na to, yan sa ating closed surface integral. No? Pinag-aaralan natin yan sa surface integrals and gagamitin natin yan dito to define ano yung divergence. Okay? Although yung quantity na yan is written as a surface integral, yung Q, kanina no, yung Q, yan, it depends on the volume na ine-enclose ng surface. Of course, kung dependent yan sa volume, it makes sense to define the flow through the surface of a clearly defined volume. No? Kung alam natin yung volume, then mas malalaman natin yung Q or the total net flow. If we do so, the quantity of Q is the flow per unit volume pala yun. No? Ibig sabihin nito, yung ating net flow is dependent on the volume or the per unit volume ng ating object. So siguro i-define na natin yung divergence given tong mga example natin na to. Yan. So the divergence of a vector A is the net flow of the flux of vector A out of a small volume through the closed surface enclosing the volume as the volume tends to zero. So, mathematically speaking, ito yung ating definition ng divergence. The divergence of vector A is equal to the limit as the volume reaches zero of the closed surface integral of the vector A divided by the change in its volume. Okay? So, hindi na natin i-derive yung ating formulas. No? Kung maaalala natin sa gradient, ang formula natin, ang formula ng gradient is equal yan sa x hat partial derivative ng ating scalar function, right? Then y hat, partial derivative ulit ng ating scalar function, then z hat. Yan. Pero dito naman sa divergence, ang ating formula is something like this. No? Ito yung ating symbol, del, we read it as del dot A. Ito yung A yung ating vector field. Okay? Vector field. So, del dot A, yan yung ating symbol or notation. Notation for the divergence of a vector A. So, kung divergence of vector F naman, yan, del dot F. Okay? So, ganyan siya, ha? Yan. Try lang natin ito. So, del dot A is equal to the partial derivative ng ating scalar component sa x. So, ibig sabihin, nandito naman ang kinoconsider natin is yung scalar component sa x with respect to x. Kanina, sa gradient or yung sa ating del of u, kinoconsider natin yung buong scalar function. And then yung result natin, nagiging vector field or vector function. Dito naman, sa divergence, ang kino-consider naman natin or kinukuha na natin ng partial derivative is yung scalar component ng vector. So, in this case, sa x, a sub x with respect to x plus the partial derivative ng ating a sub y with respect to y plus the partial derivative ng a sub z with respect to z. Sa scale, sa Cartesian coordinates, napakasimple ng ating formula. No? So isasum lang natin yan and that is our divergence of vector A. So, ganyan siya ha. So dito nilista ko na rin yung formula sa pagkuha ng divergence of vector A in terms of the cylindrical and the spherical coordinates. So, kung di nyo pa napanood yung video natin ng cylindrical and spherical coordinates, tignan nyo na lang dyan sa playlist para mabalikan ninyo. Plus, yung gradient, nandyan na rin sa playlist natin yan para mabalikan ninyo. Okay? So, yung formula natin sa del dot A is equal to 1 over R times the partial derivative of R times A sub R. So, kukunin muna natin yung A sub R and then i-multiply natin muna sa R bago natin yan kukuha na ng partial derivative. Plus 1 over R times the partial derivative of A sub phi with respect to phi plus the partial derivative of Z with respect to Z. Yan. Sa spherical naman, so 1 over R squared, so R squared yung ating denominator, times the partial derivative of R squared A sub R. Kunin muna natin yung A sub R dun sa given and then multiply natin yan lahat ng R squared bago natin kukuha na ng partial derivative with respect to R. Plus 1 over R sine theta times the partial derivative of A sub theta. I-multiply natin yan sa sine theta. Then, tsaka natin kukunin yung partial derivative with respect to theta. Alright? Plus 1 over sine theta times the partial derivative of A sub phi with respect to phi. Ayan. So, yan na yung ating mga formulas na gagamitin. Pakitandaan, lahat ng yan gagamitin natin sa pagkuha ng mga divergence ng mga vector field. No? Then later, i-describe naman natin yung divergence theorem. No? Ano ang importansya ng divergence theorem sa pag-aaral natin ng electromagnetism. So sa ngayon, magsasolve muna tayo ng mga problems related sa pagkuha ng divergence. Okay? So, I think we can start, no? So, before we start pala, so ito yung result ng ating divergence, no? If we get a positive divergence, yung movement or yung behavior ng ating vector is actually going out from a point source kung meron tayong ganyan, no? So, ang tawag natin dyan is positive divergence. Pero kung yung divergence naman na nakuha natin is negative, so papasok naman siya dun sa point source. Ganito yung itsura niya kung mapapansin nyo dyan sa illustration natin. Okay, yan. So, para mas ma-visualize nyo siya geometrically. Then we also have what we call as zero divergence. Kung zero naman yung makukuha nating divergence, yan, ganyan, parang wala siyang effect, no? Let's try a few examples. A vector field F is equal to x hat 3y plus y hat times 5 minus 2x plus z hat x squared minus 2 is given. Find the divergence of F in this particular problem. So, bago natin sagutan yan, alamin natin saan coordinate system ba tayo dapat gumamit ng formula. So, in this case, x, y, and z, so Cartesian coordinates. So, we can say that the divergence, no, del dot F is equal to the partial derivative of F sub x with respect to x plus the partial derivative of F sub y with respect to y plus the partial derivative of F sub z with respect to z. no? And kung gagamitan na natin yan ng partial derivatives, ano ang partial derivative ng f sub x? F sub x natin is 3y, no? Partial derivative niyan will be uh, partial derivative ng 3y is 0, tama ba? Plus the partial derivative of f sub y. What is the partial derivative of f sub y with respect to y? 0 din yan, no? Kasi wala tayong nakikitang y dito. Plus the partial derivative of f sub z with respect to z ops. May nakita tayong z dito, kaya gagamitan natin yan ng derivatives. Ang result natin is 2z. Therefore, yung ating del dot f or yung ating divergence is equal to 2z. Kung mapapansin natin, yung sagot natin is a scalar quantity, no? Wala tayong vector dyan. And the divergence of this particular vector, f, varies in the direction, z direction only. So, yun yung ibig sabihin ng divergence. Nasa z direction lang yung ating variation. Kung ano yung magiging value ng z, times 2 lang natin, yun yung kanyang divergence. Okay? So, siguro isa pa. Ayan. We are to find del dot A at these points. R is equal to 2, theta is equal to 30 degrees, P is equal to 90 degrees for the vector field A is equal to R hat, 0.2 R cubed P sine squared of theta plus theta hat, 0.2 R cubed P sine squared theta plus P hat, 0.2 R cubed P sine squared theta. Napakahaba, ano? So, sabi, pinapanap naman sa atin yung divergence ng A. So, direct formula lang yan. Pero dahil tayo ay nasa spherical, kailangan spherical din yung ating formula. Tama? So, ano ba yung formula natin sa spherical coordinates? Del dot A in spherical coordinates is equal to 1 over r squared, okay, times the partial derivative of a sub r or r squared a sub r. Tama. R squared a sub r. Yan. With respect to r. Plus 1 over r sine theta of times the partial derivative of r, or rather a sub theta sine theta. Yan. With respect to theta. Plus 1 over r sine theta times the partial derivative of a sub phi with respect to phi. Makahaba ng formula, no? Okay, let us substitute the values. We are to find first muna, no? Buuin muna natin yung mga kailangan kuhanan ng partial derivatives para hindi tayo mahirapan. So, 1 over r squared. Dito naman, we are to get the partial derivative ng r squared. So, magiging r to the fifth na yan, no? R to the fifth. So, 0.2 r to the fifth phi sine squared theta with respect to r plus 1 over r sine of theta times sin theta, i-multiply natin. So, magiging cube na pala to. Cube. Okay, magiging cube na yan. Right? Yan. So, the partial derivative of 0.2 r cube phi sin cube theta with respect to theta plus 1 over r sin theta times the partial derivative ng a sub p. So, kopyahin lang natin yan. R cube p sin squared theta with respect to a. So, yan siya, no? Next, solve na natin yung ating mga partial derivative muna. Hindi muna natin gagalawin itong mga factor na to para hindi naman tayo mahirapan. So, dito, we will get partial derivative with respect to r. So, magiging r to the fourth na yan, di ba? So, r to the fourth, 0.2 times 5 r to the fourth. Yan. Phi sin squared ng theta plus 1 over r sin ng theta. Dito naman, with respect to theta, so ang magiging sagot natin dyan ay 3 0.2 r cube p times 3 sin squared theta cosine theta. Okay? So, ganyan tayo, ha? Ayan. Plus 1 over r sin, oops. Ay. Bakit ang sulat ko eh. So, r sin of theta, the partial derivative naman with respect to phi, so ito naman mawawala lang yan. So, 0.2 r cube sin squared of yan. So, simplify muna natin. Hindi pa tayo dyan natatapos. I-simplify muna natin. Ayan. So, ito, magiging r squared na lang yan, di ba? Dahil dito sa dalawa na to. Dahil dito, saka dito, magiging r squared na lang yan. So, we now have 0.2 times 5 actually is 1, right? So, 1 lang yan. Kaya, r squared na agad tayo. R squared phi sin squared theta, right? Plus, dito naman sa second, 0.2 times 3. So, mangyayari dyan, 0.6, right? 0.6 times sa r naman, magiging r squared. Dahil dito, yan. And then, sa sin theta, magiging sin theta na lang siya, magiging isa na lang. Meron pang phi, no? Piyahin muna natin yung phi. Para di naman nakakaya. Yan. Phi sin of theta cosine. Yan. Plus, dito naman, magiging 0.2 r squared na lang yan. Okay. 0.2 r squared, dahil magka-cancel na to, then yung sin theta dito mawawala na rin, no? So, we now have 0.2 r squared, right? r squared sine ng yan. Now, hindi pa dyan natatapos dahil pinahanap sa atin yung divergence at a certain point. No? So, sabi, daw, that the divergence of vector A at point 2, 30 degrees, and 90 degrees is equal to, substitute lang natin lahat ng values natin dyan, no? So, r squared, so that's 2 squared times yung phi natin, 90 degrees, so pi over 2 yan, no? So, ingat kayo dyan maglagay ng degrees or theta kasi ginagamit natin yung degrees for certain applications, no? Yung mga pi over 2 sa mga ganito, no? Sine squared ng theta, sine squared ng 30 degrees is actually 1/4, no? 1/4 yan. Plus 0.6 r squared ulit. So we have 2 squared. Theta ulit na yun, no? Theta is, or phi is pi over 2. Sin theta, cosine theta. Ang sine ng 30 is 1/2. Then yung cosine ng 30 is square root of 3 over 2. So plus naman, dito na tayo sa pangatlo, ha? 0.2 times r squared. So 2 squared ulit. Sine ng theta. So sine ng theta is 1/2. So ang final answer natin, it will be equal to 3.6032. Okay, yan yung ating divergence ng ating vector A at this particular point. Okay? So, yan. Okay? So, pakitandaan lang kung paano natin ginamit yan, ha? So, punta naman tayo sa concept naman ng Divergence Theorem. Okay? So, let us consider yung box na meron tayo dito. Meron tayong sides na dx, dy, and dz. Ayan, no? dx, dz, dx, dy, dz. So, the flux, ang sabi sa Divergence Theorem, no? The flux of A, yung vector A na yan, kasi itong vector A, let's say, ang kanyang general equation, di ba? X hat A sub x plus y hat A sub y plus z hat A sub z. Yung flux daw na yan, ng vector na yan, crossing this surface, sa baba muna tayo siguro, is, so yung flux natin, no? Ganyan yung flux natin. So, lower surface equal yan sa A dot yung ating differential ng lower surface. Okay. Which yung differential ng ating lower surface, ito yan, no? Yung ating A is x hat A sub x plus y hat A sub y plus z hat A sub z dot, okay? So yung ating yung differential surface na nandiyan is, kung mapapansin natin, negative z hat dx dy. No? Dahil yan ay going to the z direction, okay, z direction, then pababa, so negative, and yung kanyang surface is bounded by dx and dy. So now, we now have negative a sub z dx dy. Okay, so tatandaan natin yan mamaya. Sa taas naman, sa upper portion naman, so normal to the surface is in the positive z direction naman yan. And yung ating component a sub z of vector A changes with the by amount d sub a sub z. Therefore, yung ating a sub z plus a particular change in a sub z is equal to, of course, a sub z plus the partial derivative of a sub z, partial with respect to z dz. Yan. So yung upper flux naman sa taas, so yung parehas na kinuha natin dito, u of s naman, yan, equal yan sa, actually, dahil ito ay negative, yan naman ay positive, no? A sub z dx dy. Yan. So, paano nang gagawin natin dyan? Gagawin natin dyan is equal yan sa a sub z dx dy plus the partial derivative of a sub z with respect to z dx or dz times dx dy. Oops! Yung ating a dx, dy, and dz, kung mapapansin natin, yan ay, hindi ako nagkakamali, ha? Ito ay dv. Tama ba? So, dx, dy, and dz is a dv. Therefore, para makuha natin yung total flux, okay, total flux, and that is the flux in the z direction, it is equal to the summation ng parehas na flux. No? Yan, flux with the upper. So, ano mangyayari dyan? Isa-sum down natin ito. Saka ito. So, ang mangyayari, negative a sub z dx dy plus a sub z dx dy plus the partial derivative of a sub z with respect to z dv. So, mangyayari, itong dalawa na to, tama ba? Zero yan. Okay? Bakit? Kasi mag-cancel lang yan, dalawa na yan. So, ang matitira lang sa atin is yung ating total flux sa z direction, equal yan sa partial derivative ng ating a sub z with respect to z dv. And similarly, kung kukunin naman natin yung flux sa x component, sa x direction, we will get the partial derivative of a sub x with respect to x dv rin yan. And sa y, we have the partial derivative of a sub y with respect to y dv. Yan. So, para makuha natin yung total flux, no, using the same rationale nung sa lahat ng yun, the total flux through this particular volume, okay, equal yan of course dun sa summation ng tatlo. Okay. So, mapapansin natin dyan, we will get this particular expression. Partial derivative of a sub x with respect to x plus the partial derivative of a sub y with respect to y, bakit sulat ko, plus partial derivative of z with respect to z dv. Oops! Di ba ito yung pinag-aaralan natin kanina na divergence? Hindi ako nagkakamali. Yan yun, ha? Diba? So, we now have the part or the derivative ng ating total flux equal to yung divergence, no? Tama ba? Times dv. Okay? So, yan na. Medyo malapit na tayo sa derivation natin. And if we are going to integrate this equation, both sides, ano ang makukuha natin? I-integrate daw natin, ha? Integrate. Integrate this with respect to the volume, and we will integrate this portion with respect to the volume then. Diba? So we are getting this particular expression that yung ating flux is equal yan sa the integral ng volume, the integral ng ating divergence ng vector A throughout the volume. And umaalala natin doon sa ating discussion with the closed surface integrals, no? We know that the same amount of flux through this surface is also equal yan sa the closed contour integral, closed surface integral ng vector A to the surface. Therefore, itong dalawa na to, alam naman natin equal yan, no? Alam natin equal yan parehas. Pangit ng sulat ko. So, alam natin equal yan. Kaya naman, we now have this particular expression, no? It is the integral of the divergence throughout a particular volume. It is equal to the closed surface integral ng ating vector. Okay? This equality between the two integrals means that the flux of vector A through the closed surface S is equal to the volume integral naman ng divergence of this particular A over the volume enclosed by the surface S. And this is called the divergence theorem. It's important use. Bakit pa natin dinerive to, no? Its important use is the conversion of volume integrals of the divergence of a particular vector field into closed surface integral. This theorem is often invoked to simplify yung mga expressions na sinosolve pa natin using surface integrals, di ba? Let's say, surface integral ng mga cube, napakarami natin kukunin dahil 6 sides yan. Mas convenient itong gamitin and mas madaling i-rewrite. Kung mapapansin nyo doon sa previous two examples natin, madali lang mag-solve ng divergence, tama? Kumpara sa pagkuha ng mga surface integrals. And we will illustrate this on a particular example. Okay, so tatandaan, the divergence theorem, okay, is the relationship ng divergent closed surface integrals and yung volume integral ng divergence ng isang vector. Okay? So, try natin mag-solve niyan. Okay. So given a vector field, A is equal to A sub x, x hat, x squared plus y hat, y squared plus x hat, z squared. Calculate the flux through the surface enclosing a cube, 1 meter on each side. Assume the cube occupies the space x from 0 to 1, y from 0 to 1 din, and z from 0 to 1. So ito yung ating illustration dito. Oops, balikan nga natin. Yan. Yung ating illustration dito. Yan. So pinapahanap daw sa atin yung flux through the surface enclosing the cube. So yung first method kasi natin dyan, actually, pwede nating gamitin yung ah, yung surface integral, no? Yung the flux is equal to the closed contour, okay? Surface integral ng vector then sa surface. And for this example, meron tayong anim na surface, di ba? Kaya naman, napakahaba niyan, it is equal to the surface integral ng A S sub 1 plus surface integral ng A ulit dot ds sub 2 kasi anim yung sides natin. So, i-rewrite ko lang dito sa pangatlo, no? Plus surface integral. Bakit ito ay dot, no? Dot. Yan. Dot S sub 4 plus surface integral sa panglima. So, kung marami kang time, pwede mong isolve ng ganito. No? Yan. Pero kung nagmamadali ka at meron kang date, pwede naman gamitin yung Divergence Theorem, which, di ba, nire-relate nga yung ating divergence dun sa pagkuha ng flux. So, yung second method, gagamitin natin yung Divergence Theorem. Okay? So, sabi, the flux na yan ay equal din yan sa the volume integral naman ng ating divergence ng vector A. Okay? And para makuha natin yan, simple lang. Kunin muna natin yung divergence and then applyan natin ng volume. No? Integral ng volume, that's a triple integral. And actually, given na sa atin yung limits, i-apply na lang natin. So first, let's get yung ating divergence. So yung ating divergence, kung di ako nagkakamali, it is the partial derivative, no? Partial derivative ng a sub x with respect to x plus partial derivative naman ng a sub y with respect to y plus the partial derivative ng a sub z with respect to z. Okay? Ayan yung ating formula. So, sagutan na natin. Equal yan sa x squared magiging 2x. Sa y squared naman magiging 2y. Sa z squared naman magiging 2z. So, yan yung ating divergence ng vector A. And now, para makuha yung flux, sabi daw, volume integral daw yan ng divergence. So, that's 2x plus 2y plus 2z dv. Yan. And since nasa x, y, and z naman tayo, no, pwede na natin gamitin yan. This equal to the integral ng z 0 to 1, integral ulit ng, palitan natin ang kulay. Pula naman. The integral ng y 0 to 1, integral ng x 0 to 1 ng 2x plus 2y plus 2z. Wala yung music natin, no? Times dx, dy, and dz. Yan. So, pag gagawin natin yan, simple lang. Yung integral ng ating sa x muna siguro, no? X. It is now equal sa, burahin ko na kaya to. Yan. Okay. So, ano na susunod natin? The integral ng z is equal to 0 to 1. Integral ng y, 0 to 1. So, integral daw ng x. So, magiging x squared natin yan. X squared plus 2y plus 2z. No? Hindi magagalaw yung iba dahil constant sila. dy dz evaluated from x is equal to 0 to 1. So, susunod, ganun din. So, dahil 1 na yan, no? Nangyayari dyan, the integral ng z is equal to 0 to 1. Y is equal to 0 to 1 ng 1 minus 0, 0 na yan, plus 2y plus 2z dy dz. And of course, ang mangyayari dyan, the integral ng z is equal to, itong sulat ko talaga. So, from 0 to 1 ng 1 plus, so yung 2y magiging y squared. Tama ba? So, yung 1 magiging y. Actually, magiging y yan. Y, tapos ito naman magiging y squared plus 2z. 2yz. No? Magiging 2yz na to. Actually, ito rin kanina. Ito magiging 2xy. Purihin nga natin. Dahil yan pala ay constant. No? Ito ay 2xy. Ito may 2xz. Yan. So, dahil sinubstitute lang natin yung 1, kaya ganito yung lumabas. Ito rin dito. 2yz. Oops. 2yz. Music nga tayo dyan. dz. Okay. So, yan na. That is evaluated from 0 to 1 din ang y. Okay. From 0 to 1. Okay. So, susunod dyan, sa z naman, matitira na lang sa atin is the integral z is equal to 0 to 1 ng 1 plus 1 plus 2z dz. Okay. So, ano nang mangyayari dyan? So, sagot natin is dahil 2 na to, 2z plus z squared. Right? Evaluated from 0 to 1. So, ang sagot natin is 3. Okay. So, yun yung ating final answer dun sa ating problem to get the flux through the surface enclosing the cube on each side. So, pwede nyo ring i-verify yung sagot ko na 3 using the first method, no, to get the summation ng mga surface integral on each of the sides ng cube. Same lang din yung magiging result. No? Paano mangyayari yon? Dun sa first kasi, magiging 1 yan. Yung sa susunod 0, 1 din dito. Then sa 4, magiging 0 yan. Sa 5, magiging 1. Then sa 6, magiging 0. Kaya ang sagot dyan actually is 3 din. No? That's the uh, proving na yung ating theory at divergence theorem, uh, na-prove natin na yung surface integral ng isang vector through an enclosed surface equal yan sa volume integral ng kanyang divergence. Okay? So, that's it. To wrap it up, we describe ano yung divergence ng isang vector field, and then we visualize ano yung nangyayari pag meron tayong positive and negative divergence, and we solve examples ng paggamit ng divergence, ng formulas ng divergence, and then we touch on tawag dito, the divergence theorem. Ano ba yung divergence theorem na yan? And we proved na yung relationship ng divergence, the integral ng divergence ng isang vector is also equal dyan sa closed surface integral. Okay? Sana meron kayong natutunan dito sa lesson natin na to, and malaking bagay na matutunan nyo yung divergence. Napaka-importante na to sa pag-aaral ng electromagnetism. Kaya lagi nyo yan tatandaan, yung formulas to get yung divergence and yung divergence theorem. Okay? With that, maraming salamat everyone. See you on the next lesson.